Hello, everyone. Thank you for joining us for today's webinar, 3 Real-World Applications of IoT Impacting Field Service. I'm Sarah Nicastro, Editor-in-Chief of Field Technologies, and I'll be moderating today's webinar. Today, obviously, we're talking about IoT, and I think IoT is something that has been top of mind for field service organizations, certainly in the past year or possibly two. And the conversations that I have with those folks, what they struggle with is figuring out what the real business value of IoT looks like for their organization. So we're in luck because today, John Klassen, Vice President of Services Support and Customer Program Management at Telit, is going to share with us 3 real-world applications of how IoT is impacting field service organizations. So he's going to share some great information with us on what IoT looks like in practice. And after his presentation, we will answer some questions. You can feel free to ask those questions as we go along. We'll get to as many as we can before the webinar is over, and any that we might not have time for, we will certainly follow up on after the event. So with that said, I'm going to hand it over to John to get us started. John?
Thank you, Sarah. Hello, everyone. And as Sarah mentioned in this presentation, we'll illustrate an overview of the combination of products and services that together create an end-to-end IoT solution and the value that these examples have brought to field services of these customers. We'll start with just a quick introduction to Telit. Telit's been solving IoT challenges for over 20 years. Our historical and primary revenue is sales of data modems. We also offer cellular data plans, IoT platform, edge agents used for general IoT as well as factory solutions, and a security product for remote access. Telit is a global company, over 7,000 customers, over 100 million connected things via modems, connectivity, platform, or combination of those 3 elements of an IoT solution. Next, let's take a quick poll here. We're interested to in just the attendees here. What stage are you at in implementing an IoT solution for field service? So if you could take a few seconds and just fill this in, complete this, and submit it on your screen. And while that happens, a recent survey responses indicated that 83% of organizations believe connected data and IoT lead to more profitable business decisions. That's what they believe, and it's proven for our customers. 76% of organizations are using IoT data analytics to establish product or process quality initiatives, so slightly different context there. The same survey respondents that are currently using IoT for field services, again, 75% have leveraged the IoT data to create advanced services, new business opportunities, new services. And our example applications today are such examples. And the most popular choice in terms of 2-year planning for IoT adoption is to incorporate IoT with service processes. So this is an area that's the most popular choice within that survey. I will just check to see where the folks here are at. So some have completed, some are in process. Almost half here in this seminar or in this webinar have no plans at this time. Move on to the survey I was referring to. It's a survey that was focused on IoT field service applications. Respondents from the survey are from a variety of industries as well as size of companies. About half the companies were enterprise companies with over 500 million in annual revenue. Just under 20% were mid-market size between 100 million and 500 million in annual revenue. And just over 30% were small, less than 100 million in revenue. So it was a cross-section of sized companies as well as you can see on the chart here, different industries. The respondents were all roles that had leadership positions and could speak on authority of the plans and investments of their organizations. So of this group of respondents, 76% had, in this case, the context is data analytics to establish product or process quality imperatives. The next slide here is field service, again, the context and adoption drivers. The highest of those that have incorporated IoT already, as well as a total of 73% either haven't or plan to in the next 24 months, is focused on customer satisfaction and loyalty. And so capturing field data and using that to increase customer satisfaction and loyalty. The next highest category here, as far as combination of have incorporated or plan to incorporate, but less have already done so, is service processes, using the data to improve service processes. And almost as high as the first category, as far as who have already incorporated IoT, are using it simply to capture product data and to optimize their products. So it clearly indicates that field services has been and continues to be a key area of investment for IoT solutions. And we see that with our customers also. So within Telit, we have a professional services and consulting group that has developed many IoT solutions and consulted with customers on solutions that they may develop in-house. We have years of experience with solutions across many industries and use cases. Many potential customers have tried an IoT solution before coming to us and failed in their first attempt. And from that, I've created some keys to IoT Solution Success. Number one, it must obviously provide business value. Otherwise, why would a company invest in it? Why would you allocate resources? Why would you give it priority as a project? Number two, it must be a reliable solution. Otherwise, the value of the data and the reputation of the solution are going to be diminished. It's not going to be viewed in a positive light. So it has to have technologies and decisions made on architecture and design that result in a reliable solution in whatever the use cases and target for the solution. There's often technical challenges also. Hardware choice can be a technical challenge. In some cases, it's not because the customer understands hardware, or either they manufacture the hardware or they understand that layer very, very well. In some cases, the customer does not understand hardware and they want to treat it as a black box. And now you have a lot of consulting work to do, really business analyst work to do, in essence, to figure out what is the right fit of hardware for that customer. And it may be environmentals, it may be technology, price points, economics, capability. Is it a proven and reliable element in a solution? Do we have experiences, and who has experience with that hardware? The communication technology can be also a technical challenge. Some customers have done a proof of concept and they've proven what works for their solution. Others have very little experience and need a lot of help. And really, the right answers are very dependent on the requirements and the use cases. We have customers that have wired connections, and if they install in an end user environment, they have to work with that end user to get that wired connection through the end user's firewall. Some customers use cellular, some have dual modems in a device. The second modem is not as much value if it's a different carrier, but on the same network. It has to be on a different network to really provide value. Some customers have satellite backup to cellular. Some will have two different backups. Maybe we have a customer that has a radio frequency and a satellite capability as backups to cellular. So there's a wide variety of technologies of just the connection as well as protocols to be used. And the economics are clearly part of those decisions also. Is the solution designed for remote diagnostics and support? Often that's not in the customer's requirements document. The customer's requirement document usually will just list the things they want to have happen. It usually does not describe what to do when an element is having an issue. It usually does not describe in detail how they plan to support and manage the solution. And that's an area that requires as much deep dive in regarding use cases as does the good path of how the data flows. And that's an area that can be a challenge for some customers to understand and come up with the right use cases. And lastly, start with a proof of concept. If a customer is trying to develop a production level solution right off the bat, it's going to have too many challenges right off the bat. Start with what's the minimal data to capture to prove that it's valuable and to prove that the technology, the chain of technologies from data capture at the sensor or hardware or device level to any edge processing to the communication stream to the cloud, whatever that connectivity technology is. And where's the destination? Is the destination a cloud analytics platform? Is an enterprise database? Is it simply visualization within the cloud? Whatever that whole sequence of events, are there VPNs involved to and from the devices, to and from the customer's enterprise? Making sure all those technologies are working together is one of the goals of just a minimal starting point proof of concept. The first example here is Restaurant Technologies. They provide fry oil. The core business is delivery of that oil to customers. Performing that with the most economical schedule is what their key to business success. Managing that cost of delivery to be most economical without never leaving a customer without new oil. So if you deliver too frequently, you're going to be incurring too much cost, but you always have to ensure the customer has oil. That's the core of their business. So they had a initial solution. It's in essence a proof of concept. It used a customer's landline as the communication, the connectivity path, and that was fraught with issues on numerous points, as well as the installation. So the goals here, objectives were a wireless telemetry solution, real-time updates from the cook and oil tanks, and using that data to streamline the routing and scheduling of drivers and field technicians to be most efficient. That's pretty simple sounding. It's pretty basic use case. It's getting data from the field to streamline their operations and improve customer satisfaction. So the solution replaced, as I said before, a previous solution that had a number of issues with reliability and success of installation. Installations included installation of RT oil tanks and electronics on those oil tanks that provide the oil levels. And there are different configurations. So at installation time, there's a per site configuration that also has to be developed. So the solution must be reliable. It must have an improved installation success rate, an improved reliability of data communications. The hardware is a mix of their electronics on site as well as third-party kitchen equipment and we selected a third-party gateway. The gateway is running a standard IoT agent from Telit. The data quantity is low. The different message types, there are different message types, each with a variety of data, whether it be from the third-party restaurant equipment other than oil tanks or from the oil tanks themselves. Some of the data requires guaranteed delivery on a timely basis. Other elements of data wanted to be captured, but they didn't have to be guaranteed delivery. The agent provides edge logic, so it provided a capability to store data if the cellular connection was down and then send it when it gets restored. Capability to do remote diagnostics, as well as updating the application, doing, in essence, a FOTA to that application on the gateway. The Edge software also forwards messages from other equipment, including any error codes from that equipment or conditions to assist in remote troubleshooting of the connections to those other items. The messages are forwarded through an IoT cloud-based platform to an enterprise database where the data is utilized by a pre-existing application. So there is a predefined message format to use and publication to the database. The solution had redundant elements in the RT Enterprise. And it started with only the capture of oil tank measurements for the initial internal customers. So that's their core business. That's what the solution started with, just capturing the oil levels allow them to do the most efficient scheduling. But it quickly evolved into capturing data from other restaurant equipment, including what could end user behavior could be discerned from what buttons are being selected on that equipment. And that end user behavior could then be fed back to the end customers, the restaurant owners or grocery stores that offer fry food. That data could be provided back to them regarding that user behavior. So that was an enhanced business opportunity and an enhanced service to end customers. Once the gateway was present on site, it can be connected to new machines or equipment. Initial challenge was to learn the unique, really of any solution, if there's unique data protocols, device protocols, or unique third-party hardware that has to be learned. You have to be able to find the documentation on it. If it's equipment from a third party where the third party wants to sell their own remote access software, sometimes it can be difficult to obtain those specifications from that third party. Another challenge can be the cellular connectivity. In a restaurant building or back of a grocery store, there could be a lot of metal in the building, maybe a lot of concrete in the building, and certain sites may have limited cellular signal strength. So then you have to understand antenna technologies, find higher gain antennas, possibly its antenna placement within the building, and longer cables running to an antenna. So it's another layer of technology that needs to be understood for certain types of installations. So those are some of the challenges in this scenario, in this example. The outcome in this case was reliable and accurate data to enable operational efficiency, their internal scheduling. There was a significantly improved installation success rate, single time visit for a successful installation. No longer had to provision through the customer's phone system. It was simply a cellular communication, a cell signal, and as long as there was a good signal and configure that site appropriately, it was a successful installation. And there's opportunities for new features and new businesses, enhanced services, as they can capture data from other restaurant equipment. So they achieved the initial goals of more reliable communications, significantly higher first-time installation rate, and then subsequently introduced enhanced services for their customers. The second example is a customer, Tenant. They provide floor and street cleaning machines. Their largest customers wanted to have feedback on how many hours machines were being used each day. They get used by the cleaning crews at night, and they truly did not know how much time was being used by those machines. So it was a very simple objective. Initially just capture hours of use for each machine per day and send that information up once per day. So it's clear business value because it's what customers were asking for. The machine controllers are developed by Tenant, installed in the machine. So they went through an engineering project, and an engineering level proof of concept that they performed was simply creating the new machine controller and testing in their own lab. That they integrated a cellular module from Telit. They worked with Telit engineers on the firmware to make it most efficient. The data quantity is very low. They only report once per day. So there's minimal cellular data use. And they developed a new controller in the firmware and had some machines that they put out into the field. And initial proof of concept from an IoT perspective was simply capturing that data in the IoT platform and displaying it on a dashboard page. So it was a very, very simple proof of concept. It didn't go beyond the IoT platform at that point in time. It was just showing that the data can be captured and proving that the data had value to it. They could see that there were customer sites where machines were only used a couple days a week. There were customer sites where the machines were used 5 days a week, customer sites where machines were used 7 days a week. They could go back and show that data to the customers, validate what the customers thought, and does this truly useful to you? And the answer was a resounding yes. So the project was to take that data and then extend it into an enterprise application, take the data to an SAP HANA database, and then have an enterprise application written on top of that database. So they had the controller developed at that point in time. And it sounds like a very simple solution, but there's still multiple levels of configuration and elements in any IoT solution. So they had the modem on the machine controller, an antenna technology and placement within the machine and the modem firmware, the cellular data plan and a VPN connection from that to the platform, cloud logic to publish to the SAP HANA database, and then the enterprise applications to be developed. There's a web service interface for customers, as well as each machine is provisioned at manufacturing time. You need to know what cellular connection is assigned, what SIM is assigned to what machine. So they have internal databases that are then configured at manufacturing time. So that's another element of this solution. And then that internal assignment then gets replicated to be assigned to customers. So these are often the minimum elements to be in any IoT solution, but there's still a number of different elements to be configured and integrated. The outcome was very successful. They had already knew that the customers wanted this data. It was highly valued by their customers, and they attributed this to actually enhancing their sales above their sales plan, these features. It can clearly be enhanced further, so that the machine controllers can clearly have firmware enhancements so they can publish diagnostics or maintenance information, and that could be used for additional service information or parts information on a service call if they can discern that by the controller. Knowing the hours of use by machine, they can help proactively schedule maintenance calls for a machine. So the data can clearly be leveraged for additional field services enhancements and improvements in their own processes. But the initial goal was simply based on the customer desire to see number of hours used per machine. The third use case is MC Machinery. They sell and service large metal machining equipment. So this solution is focused on the service portion of the business. They had no IoT solution before this project. Their goal was to reduce technical support costs. They had to send technicians to a customer site on any reported issue. They had no remote capability. And these are going into factory floors. They're going into machine shop floors. Generally, sites where there's no IT connection through a firewall to those machines. They wanted improved technical support response times. They wanted, when a technician shows up to a site, to know what parts to bring. So they have a one-time site visit success on a repair. And they wanted opportunities for new features and businesses. If they can collect all this data from their machine controllers, how can they utilize that? And that was something that was to be determined. But they knew that there was going to be value there. So it didn't start, this project did not start with an official POC, which is one of the things you should do, but it was implemented in paced stages. So initially it was simply capture data from machines and display status information for the technical support team. Again, the solution has many use cases, all served by a single web application that has multiple roles, the roles have different scopes of authorization and different scopes of what types of data can be viewed and how it's displayed. So there's a technical support set of pages in the application to view data. It includes a proactive alert list for the technical support center, their call center, where when a machine in the field has an issue, has an alert, the technical support center sees it in real time with the machine operator. Highly valued. They can be paired. They might be able to resolve it before they get a phone call from the customer, and they'll certainly be better prepared by the time they get a phone call from the customer. It also provides remote diagnostics capability, including the ability to tunnel through a gateway that's installed there to the machine controller and able to run the machine diagnostics remotely as if you were local. Very powerful capability. As well as just simply the diagnostics information if there's a parts issue, to be able to identify what part needs to be, replacement part needs to be brought on a service call if a service call is needed. And then further now they're capturing program information so they can provide production and efficiency information back to their end customers as a value-added service. So there's multiple types of machine controllers supported. They all communicate through proprietary interface to a local gateway. Local gateway can support multiple machines. Local gateway has a fair amount of edge logic. It receives different types of files from the machine controllers. They have different types of information and different purposes. If it's a program information, it absolutely must be delivered and have guaranteed delivery to the end application. If it's status information, only the most recent is important. So there's that element. The solution has logic implemented in the cloud, and this is very extensive logic. The cloud logic processes these files and puts them in data formats that are available for the many, many different use cases, the many, many different web pages, in essence, that are available for end customers as well as different internal functions at MC Machinery. It includes, for visualization, a web application and native mobile applications. Another aspect of this is there's numerous configuration elements within the solution. Configuration of machines, the type of controller they have, the protocols that the controller talks, users, sites, shifts, alerts, custom maintenance settings. Customers can identify when they want to have alerts on parts that are only good for a certain number of hours before they need to be replaced. They can configure at what point they get warnings and alerts about those to schedule service calls. This solution has very, very high level of data traffic. So in many cases, it's easier to have a solution that is cellular because you're not going through a customer's IT infrastructure. Here, that was not an economical solution because of the very high amount of data that's being transmitted through the IoT platform. So it's a wired solution, and they work with their end customers regarding the security aspects and the security provisions that are in place and how to configure the firewall to enable access from the controller to call out to the cloud. So this is not a cloud-initiated transaction. It's always a gateway-initiated transaction through the firewall to publish data. And the gateway will also initiate action and query, does there need to be any traffic the other direction? So this is a successful solution even without a POC because it was a very staged implementation. The customer learned, became an expert in the IoT technology and the products. So it was a very collaborative effort. They also recognized that the solution evolution is continuous, and it truly has been for this solution. When the issue list for all customers is displayed on the technical support call center page, do they want to, when they handle an item, do they want it removed off the list and deleted? Or do they want it moved to a secondary list to show which ones have been handled? These are the sorts of decisions that, if they have not had this type of tool available previously, they can take a guess when they put together initial requirements, but it's something that may be that answer may evolve as they start to experience and use the tool. And they may want other information available on that page. Some information may not be valuable on that page. And so the evolution of the requirements are absolutely continuous. What diagnostics and maintenance data is most valuable? We collect a lot of data. Which of those elements should be displayed most prominently? And that may, as you get a new controller, that may change also. That will evolve over time. And there may be process changes. When a machine is first installed, they have capability of uploading to the cloud the configuration file for the machine. Previously, if a customer's operator somehow trashed a machine's configuration file, they would have to send the service technician out there to reload the file. Now they can download it from the cloud, from the IoT portal. So it's a huge savings. It's an immediate fix versus a long-time fix. But it requires a time of installation for that file to be uploaded to the IoT portal. So it's a process change at installation time. So these are some of the evolutions that take place and that just over time with this solution. So clearly, the outcome of this was a significant savings on travel and technician visits because so much more was able to be done remotely, as if they were local, if it was a software issue or simply a diagnostics issue. And on the first time technician visit, they could be completely prepared to have it a one-time visit for fixing the machine. So it ultimately reduced machine downtime for customers. It added value to post-warranty service agreements. Because of the added value, the better response time, and that is all enabled from this IoT solution, their customers now are embracing post-warranty service agreements because of the enhanced value of this IoT solution. So very, very clear field service value that's embraced by customers. And then the new business aspect is the fact that all the machine program data is collected. That is now available to their end customers to view what is the productivity, what is the run versus idle time of these machines by shift, by machine, by plant. And their customers highly value that data. So, a couple summary slides here. To go back to the success factors, an IoT solution obviously must provide business value. What's the real value? Is it something that customers are, can you provide data that customers are asking for? Can you improve your service knowledge and response? Can you improve just feedback on products to improve products? It needs to be reliable. It needs to be a trusted source of data. Whoever is developing the solution, whether it's an integrator, whether it's yourself, whether you need to understand the hardware. You need to understand what communications technologies, transports and protocols and connectivity is the right one for this particular solution. Some of that might be based on topography. An agricultural solution, LoRa might be the right answer. In very, very remote situations, often it ends up being satellite. But it's a very important decision, obviously. The solution needs to be monitored and supported, as with any IT system. So are there metrics, internal metrics on just the operation of the solution elements, not just server, CPU, and disk, but if there's a buffer and a communication stream, if there's a database being used, what's the load on the database? What's the, if there are transports being used, are there any transport failures occurring? If there's whatever the important elements are of the solution, how do you create metrics that are published on an internal page so you can monitor that solution for its health and start to identify when things are not as healthy as they should be so you can take action and keep that completely operational 100% so it's a reliable solution. It's an aspect that's often not vetted out by customers until they start to get in this type of solution. You have to treat it like any other IT solution where it's monitored and it has provisions to do support of all the elements. And then start with a proof of concept. Start with something that's relatively simple and quick. It provides a method, a baseline to learn how to configure all the elements and make sure they're all working together smoothly. Are they configured correctly? Are there any other aspects of those configurations of the data plan, the communication stream, the VPN, servers, where they're installed, how they're connected, and then validate the value of the data. And once customers start to see the data, once they have a proof of concept and they start to see results, requirements often change and they'll evolve. And so that you can have a first successful production project. So benefits, Telit does have a professional services team. We're focused on IoT solutions for our customers, whether it includes Telit modules or not. It does include our platform if you're using our professional services. The services include IoT training, solution development, project management, as well as we can do solution support. When we develop a solution for a customer, we often transfer that support to the customer. We will train them, and an example of MC Machinery, because there's constant evolution of the web application, they are now supporting the web application and doing constant enhancements to that. And in the back end, they have us do full support of. We've developed solutions across a wide range of industries, a wide range of use cases, architectures, and technologies. And solution architectures are widely varied. The data could be visualized from the platform itself. It could be visualized. It could be sent to another cloud analytics platform. It could be going to multiple destinations. And how is it captured? And it could be captured through multiple technologies. We're experienced with cellular, wired, satellite, LoRa, and other connectivity technologies. Edge devices can be smart sensors, telematics devices, shop floor PLCs, machine controllers, using edge gateways, or a combination of any of these. There's standard and proprietary protocols. Some protocols guarantee delivery, some do not. And logic can be in the edge of the solutions, can be in the cloud, it could be at the enterprise, or it could be in multiple cloud platforms. There's web applications, there's native mobile applications, there's dashboards. There can be a lot of elements for destinations of the data and how it's used. So we have a pretty wide breadth of experience of delivering a wide range of projects and enterprise level projects that have the scalability, security, and maintainability. That how do you monitor them and how do you support those solutions? So all three of these solutions were developed by Telit Professional Services, and all three of these, the customers were trained on these solutions and the support of the solutions, and they have taken on various, I guess, percentages of support of the solutions. They've all taken on either all or portions of the solutions to support them going forward. So thank you. I think it's Q&A time.
Thank you, John. All right, let's dive into some questions here. So the first question is saying, the main challenge we find with cellular communication is that the constant upgrades in cellular networks is the constant upgrades in cellular networks. This becomes a major issue when thousands of devices are deployed and become unusable due to network obsolescence. Is that something you can speak about, John?
Yeah, we've clearly experienced that also as AT&T sunsets their certain technologies and embraces new ones. Yeah, we experience it, and customers have had those challenges, and some of our customers have had to constantly buy new generations of hardware. I don't think we can stop the telecoms from doing that. That's going to be what it is. I think the only answer is it depends on what type of device you're connecting to, and what type of and where you're putting the modem technology. In some cases, if you're say a tenant and you're embedding the modem technology in your machine controller, is that a module that can simply be replaced? So you're not replacing the entire controller, but you're replacing a small modem board instead. That type of answer it still requires an action to be taken in the field. But I don't think we're going to stop the change from the telcos.
Okay. So besides that, what are some of the other common challenges that companies face when they're launching an IoT solution?
I think it's Device connectivity is a common challenge. If it's cellular signal not being good, if it's some of the other technologies, if it's a wired solution, customers' IT group suddenly turning off your hole in the firewall. So connectivity is a common issue, a common challenge. After that, I think it's probably when customers have not designed the ability to monitor and support sufficiently into the solution. If they have a difficulty in determining exactly what's wrong, or actually having an indication before there's an issue in the solution that something's not healthy in the solution. If you have logic running at a gateway, how do you know when the gateway is getting overtaxed? How do you know when you're getting data that you don't expect and the logic's not able to handle that correctly? What does it do? Does it discard the data? Does it also send alerts somewhere to say, hey, I'm getting messages I don't expect from this machine controller? So those are the two of the categories.
Okay, good. The next question is, what do I need to consider in working what do I need to consider in working toward a proof of concept?
I think it's making it as simple as possible. So I like the Tenant example where their end goal was to capture the data and be able to show that to customers. But once they had the machine controller enhanced to provide the hours report once a day, the data was simply collected in a dashboard in the portal. It didn't traverse all of the paths that it wanted to initially, finally, at the end solution, just to show that the data was valuable in that case, in that scenario. Mm-hmm. And some other more complex solutions where their data might be going to multiple sources, or there's more of a challenge at the hardware level, because in that scenario they already had vetted out the hardware integration, modem integration into the machine controller. They had done all that development and testing. In many IoT solutions, that level of hardware integration is part of the overall solution development. So if you have an agricultural solution that's covering many acres and you have a LoRa solution, is it flat or is it hilly? Establish a couple sites with a couple smart sensors and have those in one of the particular fields set up with a LoRa base station. And then does the LoRa base station have good connectivity to the platform, and can you capture data as reliably as you want to? Did you pick the right LoRa sensors? So something to prove out the technologies, and then as well as proving out the value of the data. But make it as simple as possible for a proof of concept. Something that's cheaper to do. It's not the full expense of a full-blown production level project. And it won't have all the error handling paths. It probably won't have all the monitoring and support kind of features in it, but just something to prove the technology.
Okay, good. What is the typical time frame from ideation to implementation? What should a company be planning for?
Oh, that can be all over the place. We've done a proof of concept in as quick as 2 weeks, but we have projects that last 12 months also. We have projects that your first delivery might be 6 to 12 months, but it's constant evolution, and there's constant releases going on afterwards. But it varies tremendously on, is the hardware already available and proven? How complex is the software? How complex is the overall architecture? Some solutions, the production level solutions, the data goes to many different destinations. In some solutions, the data may arrive from many different destinations. We have a customer where data is combined in the platform from a manufacturing database, a dealer database, a customer database, and then they have device information is published live. And it's the first time that they have ever had all that information in the same database and visible on a single web page. But there's a lot of different elements publishing data, and so there was a lot of configuration and validation and involved in that, and it takes a longer time to put all those different elements together.
That makes sense. If I create an initial solution for one application, is it possible to reuse it for other field service applications after that?
Well, anything that's a released product that's an element can obviously be reused, whether it's an element of hardware or element of software in the solution. The IoT platform and edge gateway agents are reusable software components. Customization of edge logic and cloud logic are often per project. How much can be reused really depends on how different the two solutions are. If devices are talking different protocols, wherever the protocol is being consumed by, they're going to be different elements. You can reuse, if a customer has a solution in place and they have infrastructure that consists of VPNs and platform organizations and data plans for devices, and maybe they have a different use case, but they can reuse those elements of a solution. So it's really situational. It depends on the difference between the two solutions and the similarities between the two solutions.
Okay, good. What are some reliability issues that you encounter the most, and do you have any advice for companies on how to avoid those?
So it's similar to the first question in a way, or second question. Having sufficient signal is always an issue. Not on all sites, but there's often some sites that will have a signal quality issue, signal strength issue. Any components that are hosted by the customer in the solution, that needs to be monitored and supported also. So if a customer solution includes elements that they host themselves in their own IT data center or in their own cloud account, and solution's not working correctly, and they call us, and everything looks good on our side, they have not been monitoring their side at times. So all the elements of a solution have to be monitored and supportable, including alerts. If it's a 24/7 solution and you're monitoring it, then it needs to have automated alerts if any element stops communicating or starts to see errors or issues. So I think those are the two categories.
Okay, good. Good. All right, and with that, we are out of time for today. So, John, thank you so much for joining us today and sharing your insights. And thank you to everyone in the audience that joined us today as well. Hope everyone has a great rest of their day.
Okay. Thank you, Sarah.